So could you explain how this protein leverage works and what kind of implications it might have for humans?
Well, we were speaking about nutrient-specific appetites. One of those appetites is for protein. We have another for fat, another for carbohydrates, calcium, and sodium. Basically, most animals have those five. In balanced food environments, in normal circumstances, they use those appetites to balance the nutrient intake because each one is a means of telling behavior at a given time what it is that the body needs. And that's the way that animals and humans balance the nutrient intake. The problem, though, is in imbalanced food environments where there's too much of some things relative to other things for which we have nutrient-specific appetites, they then come into competition with each other. And the question is which one wins out in those circumstances. Protein leverage is based on the observation that in humans and many other species, protein is the strongest of those appetites. Now, what that means is that if protein is diluted in foods or in the diet, our strong protein appetite causes us to compensate for that by eating more of the food. If it's fat and carbohydrates that's diluting protein, then we eat more fats and carbohydrates. If you look at global and historical population data, that's exactly what's been happening in modern food environments, particularly with the influx of ultra-processed foods that are diluting protein relative to fats and carbohydrates. It's this dilution of protein in our food supply that interacts with our strong human appetite for protein to drive energy overconsumption and obesity. That's the protein leverage hypothesis.